This is part 2 of section 3.4. We want to solve this exponential equation right here. Now both 3 and 2 are prime, so I'm not going to be able to write these as powers of the same base. So I want to take natural log of both sides so that I can get the x's out of these exponents. So if I take natural log of both sides here, I have natural log of 3 to the x plus 1 is equal to natural log of 2 to the 2x. Now we use our power rules to move these exponents in front of the logarithms. So I have x plus 1 times natural log of 3 is equal to 2x natural log of 2. Now, natural log of 3 is just a number. It's ugly, but it is just a number. And if you get stuck here ask yourself, what would you do if it were just a 3? If it were just 3, none of you would have any issue. You would just distribute. We're going to do the same thing here. So I have x natural log of 3 plus natural log of 3 is equal to 2x natural log of 2. Now we want our x's on the same side, so I'm going to subtract this over to here. I have natural log of 3 is equal to 2x natural log of 2 minus x natural log of 3. Now what I'm going to do here is I'm going to factor an x out of this. So I have x times 2 natural log of 2 minus natural log of 3. And this is just some ugly number. I'm going to divide both sides by that. And I get x is equal to natural log of 3 over 2 natural log of 2 minus natural log of 3. That is how they would likely want your first answer given. When it's exact, and they'll ask you for an approximation. So I have natural log of 3. Be really careful with your parentheses here. And I get approximately 3.819. Okay, now when it comes to exponential equations, in the ideal world, we can rewrite both sides so that they have our powers of the same base. When that can't happen, we take a logarithm of both sides. Theoretically, you can take log of any base. Practically, it is common log or natural log, and as far as your computer goes, it is natural log. Okay? But not everything is going to be given to us in that form. So we may be given something that is in quadratic form. Now, what that means is that if you can make a substitution and you end up with something that's in quadratic form, then you solve the quadratic and then you undo the substitution. Basically, if we can put a Band-Aid over something that looks ugly and then we get a quadratic, we should do that. This is just a general reminder, actually, that we can make a substitution in a lot of these problems and at least make the problem look better while we are working it. Okay, so let's look at something that is quadratic form. The equation e to the 2x minus 4e to the x minus 5. Now, your big clue that you may have something that's quadratic in form is usually, well, you're not going to have more than 3 terms. You don't have to have all 3 to be a quadratic, but you're never going to have more than 3. And then what you're looking for is you want the same thing here and here, and ideally this exponent is twice this exponent, whatever that happens to be. Okay, and we have that here. Then what you're going to do is you're going to make a U substitution. U is the traditional letter for substitutions, U and then V if you've already used U. And generally speaking, what you want to let it stand for is whatever is right here. So my U, when I rewrite this, is going to take the place of e to the x. Now note, if I square U, I would have e to the x squared, and I would multiply those exponents, so I have e to the 2x. That means this equation can be rewritten as u squared minus 4u minus 5 is equal to 0. And this is a simple quadratic that factors as u minus 5 times u plus 1 equals 0. And then setting each of these equal to 0, I get that u equals 5 and u equals negative 1. Okay, so now what do? I have two little equations here. I was not asked to solve for u. I was asked to find x. So I used the substitution to make it easier looking to get part of it solved. Now I need to undo this. So I have two new equations to work. I have 5 equals e to the x, and I have negative 1 equals e to the x. Okay? Now I'm going to take this and switch it into logarithmic form. So remember base e, if you're going back to logarithm, and that would be log base e, which is the same thing as natural log. So switching this to back to logarithmic form, I'll have natural log of 5 equals x. And here I would have natural log of negative 1 is equal to x. Okay. Natural log of 5 is approximately 1.609. Okay. And then if I try natural log of negative 1, we have an error. And that's because the argument of a logarithm cannot be negative. The argument has to be greater than 0. So this does not exist. So we had the potential to get two answers here, but we had to throw one of them out. And having to be aware of the domain of our logarithms is something that's going to keep coming up as we go along.